Assalamu alaikum. Welcome to my channel M.Asif Math Corner. Today we will discuss about the intersection of subgroups is a group of G. Let's start the lecture. We have a theorem. Prove that the intersection of family of subgroups of G is a subgroup of G. Let's have attention in the statement, please. What we have to prove? Prove that the intersection of family of subgroups. Family of sub, what it mean? It means that let's suppose that G contain elements are contain subgroups H1, H2, H3 up to so on. So the intersection of family of subgroup means the intersection of H1 and H2 and H3 and up to so on. Means that intersection of all subgroups of G. Their intersections give us a subset which give us a set which is, may say that H. H is equal to intersection of all these subgroups. We have to prove that this H is also subgroup of G. Let's start the proof. Let's A alpha, where alpha belongs to I mean index number 1, 2, 3, 4, how much the subgroups G has. So I is the index 1, 2, 3, 4 and alpha is the subgroups of G. Be the family of subgroup of G, we have to show that the family of intersection of subgroups of G. The intersection alpha belongs to index I. H alpha means that which I explained earlier, that intersection of H1, H2, H3. This means that H1 intersection H2 intersection up to so on. This make a set which is H. So from here, if we little bit think that we know that in intersection we take the common elements. It means if all H alpha are all subgroups of G, then they all contain identity element, and their intersection which we get the H must have identity element E. The identity element is proved. So let go next. Let A comma B belongs to H. We take the two elements of H, which is the intersection of all subsets of G. Then A comma B belongs to H alpha also. Yes, we know that. In intersection, we take the common elements. If the A comma B belongs to H alpha, then they belong to H. If they belong to H, then they belong to alpha, H alpha. For alpha belongs to I, or index number, all these sets, all the subgroups of G. Since H alpha is a subgroup of G, we know that in subgroups inverses are also exist and closure law also exists. This means that AB inverse belongs to H alpha. If AB inverse belongs to H alpha, means AB inverse belongs to all the subgroups of G, H1, H2, H2 up to so on, where alpha belongs to I. Then here we prove if AB inverse belongs to intersections of A alpha, which is H, then H is a subgroup, because identity we proved earlier, commutative law hold here, inverses are present, and we know that the associative law is commonly held in all the sets we discussed. So AB inverse belongs to H alpha means AB belongs to all the subgroups of G. Then we are taking the intersection. It means that This is the common element in all the subgroups, so it will also be in H. So it's proved that H of sub H is a subgroup of G, hence the intersection of family of subgroup of G is a subgroup of G, hence proved. I hope you understood. Thank you so much.